Thank you, Admiral Y. And good morning to friends and colleagues, including those that are calling in online. First, I'd like to start by thanking JAMS for the kind introduction to be a part of this distinguished panel. So I have the privilege of working on autonomous vessel policy basically every day in my role as the Prevention Law Division Chief at U.S. Coast Guard headquarters in Washington, D.C. Prevention is a bit of a term of art in the Coast Guard, but in simplest terms, it involves things ranging from vessel standards to mariner qualifications to navigational safety. And as diverse as those issues are, they're each uniquely impacted by the advent of autonomous technology and an increasingly autonomous maritime environment. Next slide, please. So the topic of unmanned vessels is really only a subset of a broader wave of the move towards autonomy. We've seen things like Uber's testing of self-driving cars, vacuum cleaners that can map and clean your living room while you're at work, Tesla's technology developing the autonomous semi-truck. And while each of these represent recent technological innovations, I would argue that in the maritime domain, this is really the continuation of an ongoing story. If you go back to the 1960s, a steamship would have taken about 10 personnel just to run the engineering plant alone. In the decade that would follow, that number was cut in half. In the 1960s, the Coast Guard had issued its first guidance on automation and its use to reduce crew sizes. And back in the 1980s, the IMO issued the first international standards for an unattended engine room. So this is really the next phase of an ongoing move that's been happening for some time. So what does technological innovation look like today? I'll give you a few examples. So in the upper left, you have SpaceX, the well-known commercial space company, and their spaceport drone ship, which is designed to operate either in a remote controlled or autonomous setting to facilitate rocket recovery at sea. And in the lower right, you'll see the ferry Falco, which in 2018 is a joint operation between Rolls-Royce and Finn Ferries in Finland, successfully navigated under fully autonomous control. So if we can go to the next slide, I'm only going to touch very briefly on kind of where we've been at the IMO, in part because Mr. Morimoto yesterday did a great job covering it, and we heard more about it this morning. But in short, we had the IMO's embarkation on the regulatory scoping exercise, which we all know ended in 2021. And we were trying to determine how can we, in a safe, secure, and environmentally responsible manner, integrate autonomous systems into existing IMO instruments. I'm very fortunate that later this month, I'll be back at the IMO for the 110th session of the legal committee, where we are going to pick up this work. So if we can turn to the next slide, please. So I think we all know the basic framework of the scoping exercise, which had a kind of a fixed purpose, which won't necessarily continue on into the next phase. But we really anticipated a spectrum of autonomy, moving from a level 1, which is basically a status quo operation of automated processes and decision support, up through 2 and 3 with remote operations, either with mariners aboard or not aboard. And then finally, the fully autonomous degree 4, which I think most people would agree, is the most difficult from a regulatory standpoint. And that has some implications for certain Coast Guard missions that I'll discuss. Next slide, please. So why is this work so challenging? As is probably no surprise, the existing suite of IMO conventions either presuppose or explicitly reference a physically present mariner aboard. And that's not surprising given the history that up until very recent times, there was always a full suite of mariners aboard. But this does present some challenges. An illustrative example is the STCW convention. It defines the master as a person having command of a ship. I would argue that in the IMO taxonomy, degrees 1 through 3 really don't present a huge problem here. If we have either someone physically aboard or a remote operator clearly controlling the movement of the ship, it's pretty easy to draw that back to the concept, or the traditional concept of a master. But what about the 4th degree, fully autonomous? Some academics have proposed that maybe it's the design team that designed the software. Maybe it's the machine learning vessel itself. I don't suppose to have the answer to that difficult question today, but I think the work at IMO has gotten us at least closer to asking the right questions in that context. Next slide, please. So where are we going? As is no surprise, the great opening comments in the keynote we had this morning, we're moving towards the mass code, something that will, in the typical IMO fashion, start in the form of non-mandatory recommendations or guidelines, and then eventually crystallize into a mandatory code. But given that broad scope of work, the IMO, I think, has wisely broken up different subgroups that are working on this. We have the Intersessional Correspondence Group, which I'm happy to continue to be a part of. The Joint MSc Leg and Foul Working Group, which will reconvene again in person in April. And then IMO, at the end of last year, hosted a 2-day mass seminar featuring some of the leading voices in academia, industry, and in government working on these issues. So next slide, please. So what has been the U.S. Coast Guard's response from a policy perspective? It's certainly been no surprise to us that the rapid pace of autonomous technology is coming. Some have already noted that some of it is already here. And we've tried to respond to that in policy, primarily through Policy Letter 2201 that was issued in February of 2022. And these are guidelines for human supervised testing of remote controlled and autonomous systems. This allows for testing, as the name would imply, of autonomous systems, but with a human crew on board. This, in our view, allows industry to innovate while also helping inform the Coast Guard about how to regulate in this space, which is one of our primary roles. The policy letter also ensures a measure of consistency from one Coast Guard district to another for how Coast Guard commanders are approaching these requests to test autonomous systems. The policy letter also calls for risk assessment, an assessment of a variety of risks such as navigational safety and engineering aspects to ensure that the MTS or the marine transportation system is safe not only for autonomous systems, but also your everyday users. Next slide, please. So I want to talk a little bit now about how we've integrated into naval operations autonomous systems. Like I said, we're not only a regulator of the technology, but we're also a consumer of the technology to advance our work. So we had as early as 2007, the US Navy issuing master plans for unmanned surface vehicles. You'll see a picture in the upper left of the US Navy's Sea Hunter, a 130-foot USV capable of autonomous or semi-autonomous operations for up to 70 days without replenishment. And then in the lower right, you'll see the Coast Guard 29-foot RDC. So this is our standard 29-foot hull, which is used by our Research and Development Center, but has been outfitted with a suite of technology that allows for remote and autonomous technology. Coast Guard has also invested in how autonomous systems can increase our maritime domain awareness. In 2020, we advanced a $1.8 million contract for operation of unmanned surface vehicles, the goal of which was to increase our maritime domain awareness in the remote Pacific. Next slide, please. So let's get into the operational impact of autonomy. And I thought for the discussion with this seminar's topic, I'd go to two of the core missions of the United States Coast Guard. And that's our counter-drug mission and our search and rescue mission. So we'll start off with the counter-drug mission. Next, please. One more click. Thank you, and one more. So how might autonomous systems improve the efficacy of our counter-drug mission? Among the many challenges of our interdicting narcotics at sea is patrolling vast operating areas. This is what we typically refer to as the tyranny of distance. The Western Hemisphere Transit Zone, where a number of drug trafficking routes exist, covers about 7 million square miles. To cover such a vast distance, of course, strains our limited group of enforcement assets. And by using autonomous technology, we can sort of shrink the playing field that we're seeking to interdict the assets. So some of the immediate benefits that we see of autonomous systems in this area: greater presence, greater endurance, reduced fuel consumption and eliminating the need for lengthy crew rest periods that interrupt operations, and also potentially reduced operating costs. And we'll turn to the next slide and see the other side of the coin. Next slide, please. Next. So unfortunately, the US Coast Guard and Coast Guards in general are not the only players in the autonomous vessel market. I think when we look at the history of drug trafficking at sea, we really see a story about technology. In the upper left, you see a picture of a trawler. Originally, this was a common area for concealing drugs. In the next slide, you'll see the high-speed go-fast vessel. When we got quite advanced in interdicting those high-speed vessels, you see the next evolution in technology, which is the SPSS, the self-propelled semi-submersible, or the drug submarine. So I think if we follow out the logical progression of this technology, you might ask, where will be the next phase of illicit trafficking? And I think we can assume that either remote controlled or autonomous technologies is something we will see. Next slide, please. Now we'll move to the next mission, the duty to render assistance, or the search and rescue mission. The introduction of autonomous technology does raise some unique questions. Of course, as we discussed yesterday, the duty to render assistance is reflective of customary international law under Article 98 of the Law of the Sea Convention. It's also reflected in SOLAS. And when we look at the text of that obligation, it's really referenced to the flag state, but the flag state is to require the master to take the substantive action. So in the context of search and rescue, the question of who, if anyone, is the master of an autonomous vessel takes on great importance. For our purposes today, it's enough to say that there have been no definitive answers to who the master of a given mass is, particularly at levels 3 and 4 in the IMO taxonomy. And doing this and determining who exactly that master is and what responsibilities follow that master will be some of the many important questions that the IMO has to take up. And turning to the next slide, please. This also has some particular importance for naval and Coast Guard forces. We apply by policy that obligation for the commanding officer of a vessel to divert to render assistance in the event of an emergency at sea. I did want to highlight for everyone the Commander's Handbook on the Law of Naval Operations, the most recent edition of which came out in 2022 and specifies, as you'll see at the bottom, that unmanned systems may be designated U.S. ships if they're under the command of a commissioned officer or manned by a crew under regular armed forces discipline. Many of you will recognize that as the warship definition, even if that vessel is commanded by remote or other means. So it'll be interesting to see how in the coming years, by policy, the Navy and the Coast Guard integrate this responsibility to render assistance to a potentially remote master. And we'll move on to the next slide, please. So just very quickly, going back to the IMO taxonomy, again, touching on what I said at the outset, it's fairly clear in a 1 through 3 scenario where there's someone aboard, how to render assistance. But I think an interesting question arises in degree 4. Do we expect a machine or perhaps a programmer to integrate the duty to render assistance into a fully autonomous system? Next slide. I did want to talk about vessel classification. I think most academics, and certainly I would say a majority of IMO states, have found that most autonomous systems are going to be classified as vessels, given the quite broad definition in US domestic law of what a vessel is and how courts have interpreted it. In the United States, the Supreme Court has weighed in on this question and described a vessel as, under a reasonable observer test, the structure or watercraft's physical characteristics and activities would be considered designed to a practical degree for carrying people or things over water. I think most craft that we evaluate will fit into that broad definition. But an interesting area kind of on the margins of that definition is, what about a vessel that just has a sensor package on it? Is the sensor package considered things that are being transported, or is that something less than that? And could that potentially be something less than a vessel? And moving to the next slide, the reason that I bring that up is because the entering argument for the fleet of, or the entire kind of suite of US regulations and standards that we ensure maritime safety and security with begins with that definition. Are you dealing with a vessel? So it's a very important determination in our work. And moving to the next slide, it just gives you some additional examples. Please click through this. Additional examples in our, next slide, please. And you can just keep clicking. There you go. So additional parts of our regulations that specifically use this terminology of a vessel. And finally, we'll turn to navigational safety with the next slide. So I only have time to really touch on 2 rules. They come up time and time again with respect to navigational safety and autonomous vessels. And those deal with the coal regs. So we have Rule 5, lookout, which I'll address first, and then Rule 2, the responsibility provision. So Rule 5 states in relevant part that every vessel shall at all times maintain a proper lookout by sight and hearing. And we can turn to the next slide to look at that text of Rule 5. So the ability of an autonomous vessel to comply with Rule 5 turns on what is meant by sight and hearing. For example, whether a sufficiently robust suite of either audio or visual sensors or both could serve as the functional equivalent of a human to satisfy Rule 5. But I would note, as others such as Professor Craig Allen have noted, that unlike SOLAS or STCW conventions, the COL regs do not include provisions for things like substitutions and equivalence. So it makes that Rule 5 question about equivalence that much more important. And relatedly, looking to the next slide, we have Rule 2. Rule 2 notes that responsibility within the meaning of the COL regs includes any precautions which may be required by the ordinary practice of seamen. Now, this language was not lost on the IMO Intersessional Working Group en masse that noted that this was human-centric wording that exists throughout the COL regs, including Rule 2. I would also highlight that other bold text on here, which says that the rules not only require general responsibility to follow the rules, but also to depart from the rules when necessary to avoid immediate danger. And I think that's really one of the key, it's illustrative of the technological challenge that's in front of us. It's one thing to program a mass to follow rules, but I would say the harder question is, how do you program a mass to know when to break the rules? And I don't think the technology has quite figured that out yet. Understandably, difficult question. So in conclusion, while these questions have no easy or settled answers, the Coast Guard is committed to ensuring the safety of navigation and the protection of life and property, including the safe operation of either remote controlled or fully autonomous vessels. To that end, in 2021, we established the Coast Guard's first automated and autonomous vessel policy council, the AutoPOCO. I serve on the AutoPOCO, and among other duties, we coordinate the development of policies, procedures, and actions to help safely address these new systems. So I'm right at the end of my time, and I'll stop there. I thank you for your attention and welcome your questions.
Yes, sir. Thank you very much, Commander. You are right on the time frame, and this is a Coast Guard. Thank you very much. Yes, sir. Thank you very much for providing us with the very wide-ranging perspectives from MAS, not only from the commercial shipping perspectives, but also from the military, paramilitary, or law enforcement perspectives. And that was very knowledgeable. And we are very pleased to share this information with my security counterpart colleagues in Coast Guard. Thank you very much. I don't see any online questions, so may I first invite the question from the floor, if anybody? Or I can also ask the panelists for questions if you have any. Yes, please, the gentleman in the front row.
Hello, can you hear me? Okay, I think this is basically a question about terminology, which I think we are still discussing, and the concept of full autonomy, which I'm not very much in favor. But I think your point is extremely good, that it's very difficult to foresee that you can operate a ship without somebody in charge legally, and that has to be a person. And that, in a sense, precludes this idea of full autonomy. Any comments?
Thank you. It's a great question. I think, for folks who spent a lot of time at sea, the term that you hear time and time again is seaman's eye. And I think it's the consolidated experience of a number of years operating in the gray spaces where the rules don't fully cover it, and there's a certain amount of intuition that's developed about when the vessel needs to maneuver to avoid collision, or a event that is 4, 5, 6 minutes out, but in the making, and then taking those early actions to avoid collision. So I think that's certainly part of the challenge, is how do you take something that is fundamentally a human intuition built up over years of experience and write it into a program code? And I don't think that's easily done. I try not to be pessimistic, because I think technology has shown us time and time again that it takes things that were once considered impossible and makes them possible. But I think we also have to have a healthy level of humility about just how capable seafarers are over time in recognizing certain situations. Great question.
Thank you very much. Yes, I see one more question from the floor, please.
I'm not sure whether this is much of a question or just a sort of an ongoing part of the conversation. My name is Robin. I run a very small but fast-growing search and rescue organization. We have a lifeboat station in Kamaishi in northern Japan. We have a training center here in London, And we have a training center in South Wales where we also build small ribs for mainly inshore work. But a lot of our work is working in the refugee crisis in the Mediterranean, where at the moment we're seeing high peaks in drowning rates in the world, and widely kind of prevented action of NGOs out there trying to operate in that very grey area. I have already sort of seen, I might have mentioned this in a conversation with you before, but I've already seen the sort of the advantages of having things like drones to do lookout, which is really, really enhanced the kind of range in how we can look out very, very rapidly.
Sure.
And for that, I think that search element in the search and rescue is really, really, really important. The rescue or the active rescue suddenly becomes very complicated when it tends to relying on automated devices. And of course, that actual moment where you have mass casualties in the water. So excuse the pun of using the same word, but the mass casualty situation where there are sometimes 100 to 200 people in the water in that situation, where for me, the idea of a fully automated device in that environment frightens me slightly because of that moment of interface between your casualty and what's going on the vessel, and the potentials for if a device goes wrong. I'm not sure if this is a question or whether it's just something that I'm interested in people's comments or thoughts from that trajectory or from that angle.
Sure. Thanks, Robin. Yeah, it's a great question. And I thought it was interesting, Commodore Fensha's point yesterday that in the search and rescue mission, I think at this point, there's a lot more optimism on the search component of an autonomous system, maybe less confidence in the rescue portion. So for something like a mass casualty scenario, whether it was a plane crash or something like that, you would certainly not want a mass doing more harm than good in terms of the rescue portion, particularly if it's taking in a lot of inputs as far as location of personnel in the water or having to avoid perhaps personnel in the water if there's low visibility. You'd certainly want to avoid doing any more danger. I am somewhat optimistic. You know, as I was researching for an article on this topic, one of the quotes that I came by was that to a person in the water, something is better than nothing. So I'm not so pessimistic about the ability of, you know, at some point a mass system that could deploy temporary shelter, that could deploy a life raft, that could deploy water or a tarp, something that is not necessarily entirely sufficient in terms of rescue resources, but something that maybe is a bridge to allow somebody to survive or get out of the elements for long enough to have a more capable response asset. So those are kind of my general thoughts on the topic. Thank you.
I'll ask this question probably later, but about the kind of aspect of training young people to get into this environment, which is what I'm in the business of at the moment, is training young people and how they get involved in that process.
Thanks, Ron.
Okay, so thank you very much. I see one more question from the floor, but because of the time, I need to switch over to the next speaker, if I may. So we have the Q&A time later. So please, thank you. Once again, thank you, Commander, for giving us with the very detailed. We are not narrowing down the perspective into the real Coast Guard world. Thank you very much, Commander.
Sure.
So I would first next invite Professor Anna Pedrick from the University of Basel. Many of us may remember that Dr. Pedrick suggested a new few important points regarding the law enforcement aspect of mass in the RMO online seminar last year. So I was looking forward to listening to her high-level insight again. So Anna, take the floor. The floor is yours.